Welcome to Engineering Studio with Dr. Mohammed Tahir. In this video, we are going to discuss about the types of beam section. So we will study how we can differentiate between compact, non-compact and cylinder sections for beams. So depending upon the stability, sectional shapes for the beams can be classified as compact section, non-compact section and cylinder section. So first of all, what is a compact section? A compact section is the one that is capable of developing its full plastic moment capacity, mean yielding of complete section before any local buckling occurs. So a section will be termed as compact if the whole section can yield without any local buckling of this flange or the local buckling of this web. So in order to qualify under this category, a member must meet the following requirements as specified in the AISE specifications. Web is continuously connected with the flange. So the web of the member should be continuously connected with the flange. So if we see the section, so it should be continuously connected with the flange. So web should be connected with the flange. And the second is flange local stability criteria is satisfied. So there should be not any local buckling in the flange of the section, and the web local buckling criteria is also satisfied. So in the next slide we will see what are the web flange local stability criteria and web local buckling criteria. So first of all, flange local stability criteria are flange local buckling. The flange is locally stable when the width over thickness ratio, which is denoted as lambda, for the flange is lesser than the limiting slenderness ratio parameter for compact elements. So if this lambda is less than lambda p, so we can say our flange is locally stable. There will not be any local buckling of flange. So the parameter lambda for flange may be calculated as bf over 2tf or bf over tf. So either we can consider this much portion and its thickness, so we will write bf mean the total flange width divided by 2 times thickness of flange, or we can use this bf over tf. For example, if we have a channel section, so in that case this much will be bf and this much then divided by the thickness of this flange or thickness of this leg. So we can calculate this parameter which is termed as lambda. So once we have this lambda, then we need to compare it with this lambda p, and for the value of this lambda p we can consult the table B4.1b of AISE specification, and this is for unstiffened flanges, because if we see a W section, so this web is a stiffened element and this flange is a unstiffened element. And what is stiffened and unstiffened elements? We have covered this topic in the previous video in the chapter of compression members, so you can consult that video. So here I have reproduced that table, so we can select the limiting value of lambda p for different cases. For example, if we have this W section, so this will be B, the width of flange, half flange and the thickness of flange. So B over T ratio, it should be 0.38 square root E over Fy. So from here we can select the limiting value of lambda p, and the lambda of our selected section should be less than lambda p. If this is so, we can say that our section is a stable section against the flange local buckling. Okay, next criteria is for compact section is web local buckling criteria. So web is locally stable when the following condition is satisfied, mean lambda should be less than lambda p, and here the lambda is h over tw. So h is the twice the distance from the neutral axis to the inside face of the compression flange less the fillet or corner radius of the rolled section. So we need to understand that. So if I draw the section, so it will be like this. Here we have a fillet radius. So the distance from neutral axis up to this fillet radius on this side and up to this, so this much distance will be h. So we can select this value, how much is the fillet radius. So this value is given as a k value in the LRFD manual. So from there we can select this k value, and then d minus 2k will give us h value. So d is the total depth, and if we subtract k on one side and k on the other side, so it will give us the h value. So once we have h value and thickness of web, so we can calculate lambda, and we need to compare it with the lambda p. And as this web is a stiffened element, so for stiffened elements in the same table, the parameter lambda p is given for stiffened elements. So we can select h over tw, for example, for this w section. So this much will be the limiting value. So the lambda of the selected section should be less than this limiting value lambda p. So we can summarize that a compact section will be a section for which the web is continuously connected with the flange, and lambda of flange is less than lambda p per flange, and lambda of web is less than lambda p of web. So if all these three conditions are satisfied, so then we can say that it is a compact section, and we need to check these conditions for all the element of the section. For example, if we have a section like this with different width of flanges, so we need to apply the check for lambda on this flange as well as on this flange. And if the width of or the thickness of the flanges, for example, we have the same width of flange but the thickness is different, then again we need to check for all the flanges. Similarly, we need to apply the check for web. So if both the web as well as flange satisfy the criteria, lambda is less than lambda p, and web is continuously connected with the flange, so we can say it is a compact section. So next is non-compact section. So a non-compact section is the one which can develop yielding at least on one of its outer edge before showing local instability. So if we have a W section, so when it is subjected to the loading, so some part of it will be yielding, but the remaining section will not be yielding, and before the yielding of the remaining section, the flange can buckle or web can buckle. So if this is so, we can say it is a non-compact section. So a section can qualify for the non-compact section if the lambda of the flange, for example, is greater than lambda p but less than lambda r. So if this is so, and similarly lambda for web is greater than lambda p for web and less than lambda r for web. So if these two conditions are satisfied for all the elements of a section, then we can say it is a non-compact section. Again, we need to apply these conditions for all the elements. For all the flanges, if the flanges have different thickness or different width, and we need to apply this for the web. Slender section is a section that cannot develop yielding at any point within the cross section before it shows local instability. The width over thickness ratio of any element exceed lambda r. So if width over thickness ratio of any element exceed lambda r, then it will be termed as slender section. For example, we have a W section, its web, its flanges satisfy the criteria lambda is less than lambda p, but its web does not satisfy, and in case of web, the lambda is greater than lambda r, so it will be termed as slender section. So only web does not satisfy the criteria of compact section, and it lies in the range of slender section, so the whole section will be termed as slender section. And the limiting value of lambda r can be selected from the tables B 4.1b of AIS specification, as we have seen earlier. So we can see over here. So here the value, limiting value for lambda r are also given for different elements, and in the previous case or in the same table, the values for unstiffened element are also given for lambda r value. So we can select the value of lambda r and lambda p from this table, and we can compare it with the lambda p over t ratio of all the elements, and then we can compare it with lambda p and lambda r and see whether it satisfies the criteria of compact section, non-compact section, or slender section. So if I summarize, so we can say a section which have only one element which does not satisfy or for which the lambda is more than lambda r, so in that case it will be termed as slender section. And if for a section only one element have the case that lambda is more than lambda p, so then it will be termed as non-compact section. And for a section to be compact, its all elements should satisfy the criteria lambda is less than lambda p.